Hello, welcome back. So this section I'm going to look at genetic testing, which is B1.3 from the specification. So this section looks at the uses of genetic testing and then the implications of it. So what are the ethical issues of it? So before we move on to look at that, just a very quick recap of what you need to remember. So these are the symptoms of cystic fibrosis and Huntington's disease. So Huntington's is obviously dominant, cystic fibrosis is recessive, and you need to learn all these symptoms of each. Okay, now don't forget that with Huntington's, if one of the parents has Huntington's disease, then there's 50% chance of the children having it. So the way we can work that out is obviously by these Punnett squares. So this is just an example. So if one of the parents, here we've got the dad, it could be the dad or the mum, it doesn't make any difference, there's 50% chance that those children will have Huntington's disease. If somebody has cystic fibrosis, if the parents are carriers, then they won't necessarily show the disorder, because remember, the dominant allele, if you have one dominant allele, then that's what is expressed. So if two parents are carriers, then children, there's 25% chance of their child having cystic fibrosis. So these people would want to know whether they are a carrier, whether they actually have the disorder, particularly with Huntington's disease, because it's late onset. So they wouldn't necessarily show any symptoms until they're in the 30s, probably 40s, and then they would start to show the symptoms. So what you'd be asked is, what are the implications of genetic testing, and then what are the uses of it? So the uses I've put here in red, so anything that I write in red is going to be the uses, and anything that's in black is the implications. So the first use is predictive. So what they will do is they will use it to be able to check whether somebody has that faulty allele or the faulty gene. Now remember, back to yesterday's clips, so if somebody has a faulty allele, remember there's two alleles for each gene, and if somebody has a faulty allele, then they may be a carrier of a particular disorder. So the reason, what the implications are of that is the fact that it's not always accurate. So sometimes there's what we call a false positive, or you could even have a false negative. So they're not accurate. So somebody might be told that they've actually got the disorder when they haven't. Somebody might be told they haven't got it when they actually have. So that's always an implication. If somebody is told that they have a particular allele, then they'd have to make the decision whether to have children or not. So that is obviously an implication there. Now the other thing is, on the plus side, it would give them the opportunity to be able to find suitable medical treatment and medical help and support, particularly if they have one of these disorders. So that's an advantage there. Now, still linked in with this, another implication of predictive testing is to society, which what they link to society is basically who should be told. So some people think that employers should be told if that person has that particular faulty allele or faulty gene, if they're going to pass it on. So it's whether employers should be told, but also insurance companies. So some people are worried that, of course, should this information be shared with insurance companies, which would then lead to them either not getting insurance or the insurance costs going up. So that's what predictive tests are. Now, the other uses of genetic testing is what we call PGD, which is pre-implantation genetic diagnosis. What that means is that they test the embryos. So they'll test the embryo at the 8-cell stage. So once it gets to the 8-cell stage, they will actually test that embryo, and they'll take a cell out of that embryo and see whether it carries that faulty gene. Now, that'll allow, of course, the parents to be able to potentially have a healthy child that is free from that genetic disorder. However, it's still not always accurate. So some of these embryos might be destroyed because of a false positive test. Some of them may be implanted and might actually still have that disorder. So it's not always accurate. So again, you've got false positives and false negatives. It can be used as well by people who are carriers, so that's an advantage. So again, link back to these Punnett squares, you can actually use this for people who are carriers who wouldn't show the disorder to be able to have a potentially healthy child. Of course, the other ethical issue is that if those embryos are actually tested and they have that faulty gene, then those will be destroyed. So faulty embryos will be destroyed, which some people think is, obviously it's against their religious beliefs. So that's some of the other uses and implications of PGD. Now, the other thing that we need to think about is testing before prescription drugs are given. So potentially you can actually have your genes tested to be able to check whether the drug would work or not. So testing for prescription drugs before they are prescribed. Now again, thinking back to yesterday, the reason for that is because a gene, which, thinking back to yesterday, this is a gene, and a gene codes to make a protein. So if somebody has that particular gene, then they will make a particular protein, such as an enzyme, and that enzyme will mean that the drug will be able to be broken down, because what happens in your liver is when some drugs that have potentially harmful side effects have actually increased, then if they haven't got that enzyme, then the drug can't be broken down, which means that they'll get some nasty side effects. So if somebody doesn't have that gene and they don't make that enzyme, then there's some quite nasty side effects. So again, the advantage of that is it can prevent side effects from drugs.